Hi, welcome to ASVAB Tutoring. So here in this tutorial, I will solve various problems about the complex numbers. So here's the addition, subtraction, multiplication, division, modulus of a complex number, argument of a complex number, conjugate of a complex number, polar form. How can we calculate the polar form? And De Moivre's law. So De Moivre's law is very important for the competitive questions of answering. So here solve a quadratic equation with a complex solution. So let's go for the first problem is here the addition. So first we need to add the two numbers. So here when you solve like real number is like 3 plus 2 equals to 5, and the imaginary number will be go for 4i minus 3i. 4i minus 3i equals to I. So here we will get the number is like 5 plus I. So here this is the addition for the complex number. So now come to it's a subtraction. So here also we need to subtract like this way. So here 7 minus 5 equals to 2, and here also plus 2i, and it's a minus multiply with minus. So minus times minus will give me the positive result. So here also it's a positive 3i. So we can convert it like 2i plus 3i equals to 5i. So we get the numbers complex number after the subtraction. It will give me 2 plus 5i. Now come to another problem is here it's a multiplication. So 4 plus I times 3 minus 2i. So here 4 times 3 equals to 12. 3 times I equals to 3i. It's a plus and minus, so it gives me minus value. So 4 times 2 equals to 8i, and here also plus and minus, so it will give me minus 2 and I square. So we will give the result like this way, 12, and here also 3i, positive 3i and negative 8i, so it will give me minus 5i minus, so I square. So I square value equals to minus 1. So here we can put down minus 1. So 2 times minus 1 to give me 2 answers. So as negative times negative will give me positive result, give me positive 2. So it's a positive 2, and here also positive 12. It will give me 14 minus 5i. So this is the answer for this multiplication. So let's go for the another problem is here division. So how can we divide the two complex numbers? So here 6 plus 2i divide by 3 minus I. So here we will solve like this way. It's 3 minus I is the denominator for this expression. So we will multiply for ups and downs, multiply with the numerator and denominator with 3 plus I. So it will give me like 6 plus 2i, and here also 3 plus I, and we will take like 3 minus I times 3 plus I. So we can cut off from this here, but we need this expression. So here 6 times 3 equals to 18 plus 3 times 2 equals to 6i plus 6 times I equals to 6i plus 2i times I equals to 2i square. So here over 3 times 3 equals to 9. 3 times I equals to minus I 3i plus 3i, and here also minus and plus. So minus times plus equals to minus I square. So here we will get like 18 plus 12i, and here 2i square. So it will give me negative 2 because I square equals to minus 1. I square equals to minus 1. So it's a negative 2. Now we will calculate like here 3i minus 3i plus 3i, we can cut off both. So here also it's a 9 minus I square, so I square equals to minus 1, so minus 1 times minus equals to plus 1, so it will give me the answer like 10. So here 18, so not 18, so it will give me the answer like, it will give me the answer is 18 minus 2, it will give me 16 plus 12i over 10. So here 2 is a common denominator for both the cases, so you can simplify more like this way. So 2 times 8 plus 6i, and here also 2 times 5, so it will give me the final answer like cut of 2, and 8 plus 6i over 5. This is the answer. Now come to another problem is here. Find the modulus of complex number z equal to 3 minus 4i. So z equals to 3 minus 4i. So here the normalized equation is like z equal to r cos theta plus I sin theta. So this will be the normalized equation. So here r equal to tan inverse sin theta over cos theta. So we need to calculate like this way. So here first we need to find out the value of modulus. So here modulus of z equals to 3 a square plus 4 square equals to 3 square is 9 plus 4 16, so whole it's a square root of 25 will give me the answer 5. So here the value of r equals to 5 like this was. So here the find the modulus of complex number equals to z equals to 3 minus 4i. So here the modulus of z equals to 5. Here is the answer. So now come to another problem is here like find the argument of the complex number z equals to 1 plus I. So how can we calculate the argument? So here arg means argument of z. Argument of z equals to root over 1 square, it's a real number, plus 1 also, here is the 1 times I, so here also 1 square, we will get root over 2. This is the argument of z. So now come to another problem is here find the conjugate of the complex number. So z equals to a plus a minus ib. So a minus ib equals to the conjugate of z equals to a plus ib. Here also we can take plus minus. So here also z equals to conjugate of z equals to 5. So plus minus modulus of 5 plus 2i. This is the answer. So now come to another problem is here express z equals to 3 plus 4i in polar form. So z equals to 3 plus 4i. So what is the normalized equation is here r means the argument times cos theta. Here it's a cos theta plus I sin theta. This is the generalized equation and polar form, inside the polar form. So first we need to calculate the argument of z like root over here 3 square plus 4 square equals to 9 plus 16 equals to root over 25 equals to 5. So we have got the argument, it's a 5, and now cos theta and sin theta. So here we find out the r value. It's a tan inverse first come to real number, and then it's the imaginary part. So now it will give me the answer like tan inverse 0.75. so it will give me like 0.75. so after this value we need to multiply with 180 over pi. So we will get the degree. So it will be the degree, and here inside the z form, like we have got the value of tangent here from r, and here z equals to 5, and cos, here how much degree we will get here, it will be here, it's a 36 point something, like 87 degree, plus sine 36.87 degree. So this will be the ultimate result for as a polar information, so polar expression of z. So this is the final. So sorry, here another problem is there is like find 2 plus I. So here we need to write down like this way, 2 here 2 plus I power cube. So 2 plus I cube, De Morgan's theorem. So De Morgan's theorem, how can we express like this? So according to the De Morgan's theorem, it's a r, so argument cos theta plus I sine theta. I sine theta, here also the parenthesis and over n is the power. So here we will get like this way, like r to the power n, or r power n times cos n theta, parenthesis is here, and I sine n theta, So here also we need to put the parenthesis, so it will close. So this will be the result. So first we need to find out the argument, like, so here argument, how can we express like this way? So it's a 2 and 1. So take r equals to tan inverse 2 over 1. So it will give me like, so here we will get the value of r equals to 63.43 degree. So here we can simplify like this way, like here r, we need to find the argument, like, so here root over 2 square plus 1 square equals to root over 5. So it's a root over 5. So here we can put down like it's a root 5, it's a cube is 3, so root 5 cube times your cos n theta. So here the value of n is 3 times 63.43 plus I sine, here also parenthesis start. So here r value, sorry, here n value is 3 times 63.43. So this will be the answer, or this will be the De Morgan's theorem we have satisfied here. So now come to another problem is here. So here x power to x square plus 4 equals to 0 for x, to solve the equation. So here x square plus 4 minus 4, here also we take minus 4, and x square equals to minus 4. So here x equals to a square root of minus 4. So the value of x is minus 4. Here we need to solve the quadratic. So quadratic equation, so it's a x square plus bx. So here there's no information about the multiplication with the x, so we can take it as 0 times x plus c. The value of 4 equals to c. So here we can now find out the value like x equals to minus b. So here b is 0. So 0 minus plus minus root over b squared. So it's 0 square minus 4ac. 4a. A means here 1. So here 1 and c is 4. And here also 2a. So 2a means 1. So here we can multiply like this way. And upward will be like root over minus 16 over 2 times a. So 2 times 1. So here 2 times 1. So here root over 16. Root over minus 16 over 2. So this will be the answer. So here we can take it as like, so the answer will be root over minus 16 over 2. So I hope there is no confusion about this solution. So if any kinds of problem you have doubt, please feel free to ask any questions, and hope you this information will be very beneficial for your competitive exam. So thanks for watching ASVAB tutoring.